In today's video we are talking about battery cells, and today is the day we will put our lithium-ion cells into their home, into their new home, into their battery shelf. And so what do we have here? These are prismatic lithium iron phosphate cells. I got them used from a seller here in Thailand for about $35 each, and one cell is 100 amp hours on a nominal voltage of 3.2 volts. Lithium iron phosphate, as I said. I could not check the cell by itself, so I'm hoping that all of them are good. I bought 48 pieces. So the plan is to connect 3 of them in parallel and then 16 of those groups in series. So it's a 3P16S configuration, and that gives us the nominal voltage of 48 volts. And at the top we will have about 58 volts, and the lowest voltage will be around 44 on this type of lithium chemistry. So to show you the cell by itself, it's, as I said, a prismatic cell with within a plastic casing, 100 amp hours. We have a nice plus and minus pole with a M6 screw terminal. Fairly heavy, 2.5 kilo per one cell, and the brand is SinoPoly. You might know this kind of cells already, maybe in a different casing. So quite good. They look all fairly good. I saw some slight damage on some of them, probably when they took out the cells from their former configuration. They made slight damage, but otherwise I've put them away and let them stand idle after I have balanced all of them, and they kept the voltage without any kind of drop. So that's why I hope they're all good. Of course, we will see when we first time charge and discharge if the performance is still where they should be. But usually, you know, lithium iron phosphate cells, they have very many cycles, up to like 2000 cycles, until they just lose about 20% of the capacity. And so they should be quite well. If they have not been abused in some sort, then nothing could have happened to them anyway. So I thought I got a good deal. We will of course see. And yeah, let's take these babies and we put them into their new rack which I have built, and prepare to connect and make a nice pack out of it. So maybe another short close-up of the cells, the terminals, plus, minus. We have nice M6 screw terminals here, and brand name SinoPoly. 48 pieces of them. We are now at our battery place, and I've built a shelf-like structure from stainless steel, and you can also already see how the battery cells will be placed into this structure. And the battery rack consists of 3 levels, and you can see there is 2 stainless steel rails basically where the cell is placed on, and in between here is a gap, and the gap, you will soon see, is meant for these plates here. These are pusher plates which will push the cells from both sides, so that they kind of stay compressed a little bit. So let me assemble now those pressure plates, and then we will continue and populate the shelf with batteries. Okay, the upper row is now populated, and now I can explain you or show you the system of the pusher plates maybe a little bit better. Why in the first place I want to compress them, you can see these prismatic cases here. They have the cell material inside wounded around each other, so when you start to charge and discharge this kind of lithium ion cells, they will expand a little bit and contract with every time you charge and discharge them, and this will cause the cell to extend a little bit in the middle, because the case material is just kind of thin plastic, and to avoid too much of a movement from the cell material inside, you want to compress lithium ion cells just a little bit. So it's not too much. You see the pressure plate, it goes from top to bottom, and there's screw rods here underneath every row. The last row is not yet finished. The upper one I protected with a PVC pipe, but with the screw rod and the final screw, I can just push together all this pack without any problem. Okay, so that was the first row on the top. It's 12 cells, and the other two rows will be 16 each of the rows, so altogether we will have our pack with 48 cells, and in a 3 parallel 16S configuration we will then get our 48 volts. So you see 3 cells minus on top and 3 cells plus on top, and they will be connected with the bus bar here, and then you jump down, 3 cells minus here, 3 cells plus, and those will be then connected with the bus bar again. So the common minus of all this battery pack will be here. Common minus, this place will be used to put the BMS, and then we will jump to the next row, and here we will have the common plus. Okay, let's continue with populating and then see the final result. Alright, the build is finished for today. All the cells are inside the rack, 48 cells, 3P16S. What is missing is the bus bars and the connections in between. We will make them next time. And yeah, you see I put some tape in front of the stainless steel frame so that we cannot short out anything next time when we connect the bus bars. The pressure is applied, and yeah, looks very clean, and a lot of power here. 15 kilowatt hours of electricity is waiting to be used. Okay, thank you for watching. Next time we will make some electrical connections and continue with the build in our AC-Powerwall project.